Hello students, welcome to this online learning platform. In semester 3 we are going to learn subject thermodynamics. This is one of the basic science in engineering. In this introductory lecture we are going to cover definition of thermodynamics, origin of term thermodynamics and application of thermodynamics. How we can define thermodynamics? It is combination of two Greek words which are therme stands for heat and dynamics stands for motion. If we combine this together, we'll get heat in motion. So thermodynamics is nothing but heat in motion, or we can define thermodynamic as science dealing with transfer of heat. When this term thermodynamics was originated, as we know, all laws and principles we have studied are present right from the beginning of the world. If we take example of heat transfer, it is basis of life on earth because continuously heat transfer is occurring from sun to earth. Means heat transfer is present from the beginning of this universe. But when we started studying it, yes, of course, when we find its need in our day-to-day life, we started studying it and making some advances in that. Similarly, when thermodynamics got its consideration, when we started commercially using steam to generate power, thermodynamic got its consideration. First, steam engine was developed by Thomas Savery in 1697. This is Thomas Savery and his steam engine. The second person was Thomas Newcomen. He developed his engine in 1712. This is Thomas Newcomen and his steam engine. But one thing we can notice here is both the engines were very slow and inefficient. Hence, they didn't find any commercial use as such. Hence, till then, thermodynamics term was not present. When it was used first, it was used first by Lord Kelvin in his one of the textbook in 1849. So we can say from 1849 the term thermodynamics was originated. Next, in 1850, first and second law of thermodynamics were developed, which are very basic principles in thermodynamics from the works of listed peoples. These are all pioneers in thermodynamics. James Maxwell, Sadi Carnot, Lord Kelvin, Rudolf Clausius, William Rankine are all pioneers in thermodynamics. We are going to study Maxwell's equation, then Carnot theorem is there. Kelvin is unit of temperature named after Lord Kelvin. Rudolf Clausius theory is there. William Rankine cycle we are going to study, which is one of the basic cycle in steam power. So all these along with many others are pioneers in thermodynamics. What is need of thermodynamics? Two obvious questions will come to your mind, which are why I have to study thermodynamics, and second question, what is practical use of thermodynamics, right? To give answer of for these questions, I will take help of three examples. First, can you see these rails? There is something uncommon here. That rail is having bend, right? Now why these bends are happening? That are because of thermal expansion. Now if such kind of bends are there, what it will result in? It will result in fatal accidents. So if we want to avoid that, what is the solution? Yes, solution is we can provide such kind of joints. These are called thermal expansion joints. Okay, so observe here, we are talking about failure of that rail because of thermal expansion. Thermal means heat is involved. So wherever there is heat is involved, thermodynamics will be present over there. At the same time, what you must observe as an engineer, we are dealing with rails which are made up of metal. So we have to study material properties, which is part of materials technology. At the same time, While designing these joints, we should be knowing how much is the extent of expansion of that metal if certain amount of heat is provided, right? That is part of strength of material. Means what is engineering? How we can define engineering? Engineering is nothing but combination of different sciences or using principles, laws, theorems from different sciences to come or to converge at universal solution. That is nothing but your engineering is. Next example I will take of this electricity grid. So these kind of electricity grids you may have seen. When they are installed, the cables will be like this. What do you think will happen in winter? In winter, because of drop in temperature, the cables will get tightened because metal contracts on cooling, right? So that cable will get stretched and tension will increase. Okay, that is the condition in winter. Now think what will happen in summer. In summer, that lines will get slacked because when heated metals will expand, right? Means because of this continuous expansion and contraction, what will happen? Stress will get generated in the cables and that may result in failure of that cable, which will be very hazardous. Now check that cables are expanding or contracting because of heat transfer. So as per our definition, thermodynamics is present over there. But check the application. We are talking about electricity grids, which is part of electrical engineering, right? So we can conclude from this slide that thermodynamics knowledge is very much essential in many other engineering branches like electrical engineering, right? I will take next example. Okay, this is girdle used for supporting bridge structure, right? If this girdle is exposed to atmosphere and if certain care is not taken, that girdle will expand unevenly and that will lead to such kind of collapse of bridge. Okay, if you want to avoid such kind of accidents, what we can do? Such solutions we have to provide. You may have seen this on bridge. Okay, this is to avoid failure of bridge because of thermal expansion, right? At the same time, see at the bottom of that bridge, you will find such kind of roller joints. Okay, you have studied this in mechanics. Now check what is application of mechanics. Here is the application of mechanics. Again check that bridge is getting expanded because of heat. Hence there is thermodynamics, right? At the same time, this structure is civil structure, right? So it is part of civil engineering. Hence we can conclude again that thermodynamic knowledge is also very essential in civil engineering, right? It is also needed in chemical engineering and many other branches of engineering. Now we'll see applications of thermodynamics. First application, this is rocket, right? It is taking away some satellite with it. This rocket is running on combustion of fuel, right? Whenever there is combustion, heat will get generated, means heat is present. So again it is part of thermodynamics. Next, recently we have purchased Rafale, which is jet engine, right? This is one kind of jet engine. So operation of this jet engine is dependent on this nozzle and combustion of fuel. So opening and closing of this nozzle and combustion of fuel will decide operation of that jet plane, right? So again heat is involved, so it is application of thermodynamics. Next, okay, students from Ratnagiri may relate this as they may have seen Jindal power plant. In Jindal power plant, similar structures, not exactly similar, but such tall structures are there, which are almost 80 to 60 feet tall. These are called cooling towers. But if I tell you that application of this cooling tower is very much same as that of oven pot, which we use during summer season to get cold water in our house, right? Now check, operating principle of both is very much similar, but its application, one is used domestically, one is used in the power plant, right? So again, heat transfer is occurring there. So in power plants, we are having application of thermodynamics. Next, you can take this as chemical factory or milk dairy. In milk dairy, we have to pasteurize milk, we have to freeze that milk to store it for longer period. So for that, we require heat to be removed from that milk or heat to be supplied to that milk. So heat transfer is there. So again, it is application of thermodynamics. Next, aeroplane. So airplane engine, it is working on combustion of fuel. So wherever there is combustion, heat will be involved, and hence it is application of thermodynamics. So as we can see, right from space science, power plants, chemical engineering and aviation, we are having application of thermodynamics. Now we'll come to our home. If you turn around, you will find number of thermodynamic applications. Our day-to-day use application, that is our bike or car. That car engine is running on combustion, right? Wherever there is combustion, heat is there. Again, it is application of thermodynamics. Next, okay, so till now we have discussed regarding all the applications where temperature was increased. Now we are dealing with two examples, which are fridge and AC, where temperature is decreased, right? We get ice from the fridge, or we reduce our room temperature using AC. So these two are applications of thermodynamics. Here heat transfer is taking place, but it is reverse heat transfer. But again, it is heat transfer, so it will be part of thermodynamics. Cooking utensils, it is best example of heat transfer. All the modes of heat transfer are present over there. Next, crew meters, it is again application of thermodynamics. If you turn around, you will find many other thermodynamic applications. Now, if thermodynamic application is within us, or our body is itself application of thermodynamics, why to go again this far, right? As I told, our body is best example of thermodynamics, or it is smart thermodynamic system. How? Check. We are taking food as an input, which is chemical energy. It is getting converted to ATP, okay, which is storage of energy. Then whenever needed, it will get converted to heat, and chemical waste like carbon dioxide, water vapors will be exhaled from the nose. At the same time, our body is continuously emitting heat, right? Means our body is doing heat transfer. So it is application of thermodynamics. Okay, why I'm saying it as smart system? Check. In winter, outside temperature will be 28 degrees Celsius. You may have experienced this, right? But what do you think will be our core temperature or body core temperature? It will be 37 degree Celsius. It will be always maintained at 37 degrees Celsius regardless of outside temperature. Okay, we'll take next example of summer season. Outside temperature will be around 42 degrees Celsius. In regions like Chandrapur, this is the temperature found, right, in summer season. So our body will start sweating to cope up with that heat. Okay, but what will be body core temperature? Again, as I told, it will be at 37 degrees Celsius only. Hence, I am calling our body as smart thermodynamic system. Next, as I told, it is one of the basic science. So we are using thermodynamic knowledge for thermal engineering, heating, ventilation and air conditioning, internal combustion engine, heat transfer, power engineering, chemical engineering and many other subjects in engineering require thermodynamic knowledge. So students, during this lecture, what we have learnt? Thermodynamics is nothing but heat in motion, or we can define thermodynamics as science which deals with heat transfer. Next, thermodynamics is one of the basic science. Yes, it is one of the basic science and used for, or knowledge of that thermodynamics is required for many other subjects. And thermodynamic knowledge is required almost in all fields, as we have seen 3 examples. It is required right from civil, chemical, railway engineering, everywhere we are having application of thermodynamics. Hence, it is very much essential to clear our basics, to clear our concepts of thermodynamics. That's all for today's lecture. In next lecture, we are going to cover prerequisites. Next point is very important, problem solving techniques. So for solving any engineering problem, there should be certain technique. So we are going to see that technique, and we are also going to discuss reference books and study material for thermodynamics. That's all for today. Thank you.